to everyone. I am Brinda Shanli, Assistant Professor Electrical and Electronics Engineering, Rohini College of Engineering and Technology, Palkulam, Kanyakumari District. In this video, we are discussing state variable model. A modern generator with its multi-stage turbine include the automatic load frequency control and automatic voltage regulator control. It is characterized by the impressive complexity. When all the dynamics are taken into account, including cross coupling between control channel, the overall dynamic model may be of the 20th order. That dimensionally it overcome by means of computer aided optimal control design method originated by Kalman. A computer oriented technique called optimum linear regulator design has proved to be particularly used in the record. So the OLR design results the controller that minimize most transient variable and control the effect. So OLR is designed for the following step: casting the system for dynamic model, for introducing the appropriate control force, choosing the integral squared error, the minimize of which the control goal, finding the structure of the optimal control, it will minimize the index. For dynamic state variable model, the load frequency discussed so far entirely satisfactory. In order to have most satisfactory control method, optimal control theory has to be used. For this purpose, the power system model must be in the state variable model. This is the state variable model of power system operation and control. In the block diagram, we can derive the following equation: del F1 of S equal to Kps1 by 1 plus S3 Ps1, del Bg1 of S minus del Pd1 of S minus del Ptl1 of S. Del F2 of S equal to Kps2 by 1 plus S del Ps2 into del Pg2 of X minus Pd2 of X minus Ptl2 of X. For del Xe1 of S equal to 1 by 1 plus S del Sg1 of S into del Pg1 of S minus F1 of S by R1, and del Xe2 of S equal to 1 by 1 plus S del Sg2 into del Pg2 of X minus F2S by R2. For Bg1 equal to 1 by S plus T1 into del Xe1 of S, and del Pg2 of X equal to 1 by 1 plus S del 2 into del X2 of S. For solving the equation and taking the inverse Laplace transform, we can found the equation d by dt del F1 equal to 1 by del Ps1 minus del F1 plus Kps1 del Bg1 minus Kps1 del Bd1 minus Ps1 del Ptl. D by dt of del Ptl1 equal to 2 pi T12 del F1 minus F2. Then the state variable is the minimum of those variables which contain the sufficient information about the past history which for future state of the system can be determined the control input. The X is called the state vector and U is called the control vector and P operation and control. In the blog, find out the formula. Thank you for watching this video.